Hello, folks. Welcome. My name is Mike Kistler. I'm a product manager on the ASP.NET Core team, and I'm here with Safia Abdallah, principal software engineer on the ASP.NET Core team, and we're going to be telling you today about what's new in ASP.NET Core. So ASP.NET Core is a complete modern web framework. It's got all the pieces that you need. It's got Blazor for rich interactive web UIs. It's got minimal APIs for fast HTTP APIs. It's got SignalR for real-time services, gRPC for backend RPC calls. It's got middleware that's built in, but also you can build your own custom middleware. And it's got Kestrel, our high-performance HTTP server. Now, we're going to be talking about mostly the back-end pieces in this talk. There's a talk a little bit later today that Dan Roth is going to be giving on Blazor. So we'll be focusing on the back-end pieces. ASP.NET Core is trusted by millions of developers, right? And it powers some of the world's largest services like Microsoft 365 and Bing, Microsoft Teams, Copilot, and Xbox. All of these services use ASP.NET Core. It's got industry-leading performance, which is one of the big reasons why we're using it so heavily here at Microsoft. And it's got all kinds of features for modern cloud applications and AI-powered apps. So this is why we're investing heavily in ASP.NET Core. Now, for .NET 10, we had a number of focus areas that we wanted to really hit hard, really make sure that we delivered in .NET 10. And those four areas are making it easier for you to build secure apps. We've been, we've been at Microsoft working on what we call the Secure Future Initiative, where we're pushing security into all of our products and services, and we want to make it possible for you to do the same kind of thing. We've improved app observability and diagnostics. This includes better logging and tracing, better support for open telemetry. We've added targeted performance improvements, and of course, performance improvements are something that we try to do in every .NET release. And we've delivered again in .NET 10. And finally, we looked at a lot of pain points or gaps that developers have been stumbling with, and we've tried to address those as well in .NET 10. The first area I want to talk about is security improvements. And there have been a lot of security improvements, as I said, but the key one that we delivered in .NET 10 is support for WebAuthn and passkeys. Now, passkeys, you may know about them, but you might only know about them in using them. The important thing from a technical point of view is they're cryptographic credentials that replace traditional passwords, okay? They're phishing resistant, but they're still easy to use and secure by design. So this is something that a lot of developers want to integrate into their applications. So we've added built-in support for passkeys into the ASP.NET Core identity framework. This is built into the shared framework, so you don't need any outside dependencies, but it was inspired by an open source project that many people have already adopted, so we know we have mature technology. Now, we didn't take all of the WebAuthn standard because some of it is still evolving, so in particular there's this feature called attestation that we felt better to leave out in .NET 10 until it really matures and is ready so that we don't have any breaking changes going forward. Our project templates, in particular the Blazor project template, now includes passkey support by default. So you just can start a new Blazor app and you'll get passkey support built in. And existing projects that have ASP.NET identity can add passkey support. This is going to require a database schema migration, but all that is described in the documentation. If you missed the keynote a little bit earlier, Safia actually showed the passkey support in the Bingo application, the Aspire Bingo application, so you can look back and check on that there. All right, now I'm going to turn it over to Safia to talk about the observability and diagnostics changes.
Yes. So being able to observe and examine the behavior of your application is really critical for managing a production service. And if you jump over to my screen, you'll see that I've got an Aspire dashboard running to showcase some of the work we've been doing on the metrics front. So here I've got an API service, and I'll go ahead and open up the OpenAPI docs for that service. Here's my Scalar documentation page, and you will see on the left-hand side, I've got a bunch of API endpoints that are actually sourced from the identity package. These allow me to register user accounts against my service, manage login, manage verification for email addresses, for running passwords, all of that good stuff. And what I want to showcase is some of the work that we've done to support metrics in the identity space. And let's do that by simulating what a user would do with our service by sending a post request to the register endpoint. So I'm going to hop in here and I'm going to put in my totally realistic test@example.com email and my extremely secure password, which technically meets all the requirements. I've got a capital letter, an exclamation point, and a number, so it checks the boxes. I'm going to go ahead and register that user account, and I'll get back a response that that registration was successful. So cool, now there's this new user registered on the back end. Let me hop into our login endpoint and register with the same credentials. Let's see if I've forgotten my password in the 2 seconds that have passed since I did this. So here's my test.example.com. I'm going to go ahead and pop in my password that I submitted and go ahead and send in that login request. Cool. I've got a 500 server error here, which is fine actually, although unexpected for demo purposes, because it's going to let me show you what I really wanted to drive at, which is the fact that all of these metrics are now populated for the identity code paths that I triggered. So you'll observe that there's this new Microsoft ASP.NET Core identity metric or meter in the Aspire dashboard. And I've got meters or metrics associated with a number of different events. I can see the sign-ins that occurred. I can see how many check password attempts were triggered on my application. I can see what tokens were generated. I can see how long it took to create my user accounts on the service. This actually ends up being pretty useful for diagnosing key issues. So for example, maybe we rolled out a new update and we're noticing, hey, there's an increase in the amount of time it's taking to create new user accounts. I wonder if we introduced a regression in that code path. We can check to see if there's a spike in the increase of failed authentication attempts, which might give us an indicator of certain kinds of user behavior. So this sort of diagnosability and observability in a key code path, particularly in the security sense, is a really great improvement to ASP.NET Core and .NET 10. If we scroll down a little bit further, we'll also see that there is a Microsoft ASP.NET Core memory pool meter. And this meter allows me to observe the behavior of the memory pool of my application. I can see when memory pools are rented or evicted, when things are allocated into my memory pool, and overall diagnose the behavior of my application in production.
Very cool.
These new metrics are on by default in ASP.NET Core. The identity ones will light up in 10.0.1. The memory pool ones are on by default. And so this is neat that a combination of the built-in features in ASP.NET Core and the Aspire dashboard give you this really amazing observability to be able to manage your production services.
Very cool. Very, very cool. All right, Safia. So next up, I think we're going to talk about performance improvements. So let's come over to the next slide. Back to my screen. Okay, well, so as you heard in the keynote, we've been really driving performance across all of .NET. And we have a set of benchmarks called the Tech and Power benchmarks that we use to measure the performance of real-world applications, going from release to release and against other frameworks. And what we found is that from our last LTS release, .NET 8, going to .NET 10, we've had an improvement in throughput, requests per second, of about 15%, and a decrease in the working set of about 93%. These are very significant improvements. Now, this isn't all improvements that happened in ASP.NET Core, because obviously there were improvements all the way through the stack in .NET, right? But we're reaping the benefits of it. You can reap the benefits of it by moving to .NET 10. A couple of things that we did specifically in ASP.NET Core was we improved the way Kestrel memory pools were managed. Previously, the Kestrel memory pools were expanded to meet incoming workflow, but then that memory stayed in the pool and was never released. So we've changed that in .NET 10, so now that memory can be returned to the system and used for other purposes. We also improved JSON deserialization performance, and this is the second half of what we did in .NET 9, where we improved the JSON serialization performance. And this is specifically with doing streaming deserialization, so that we can actually stream the JSON through the deserializer and have it all happen without having it to be done all at once. And just real quickly, the way that the Kestrel memory pool is managed, we did some micro benchmarks on this, and what we found is that you can ramp up that Kestrel memory pool as it's needed, but then once the load declines, then you can start to see that memory pool memory get evicted, the total memory declines, and now that memory pool memory has been returned to the system and can be used for other purposes. And the result is that you get better scaling, lower costs, smarter resource use. This is something that we did for the app services, Azure service, but it will benefit your apps as well. All right. Next, we're going to talk about addressing pain points and gaps.
Yes. We did a bunch of sparkle work on that front in .NET 10. We care about making the framework better with every iteration, and sometimes that means focusing on the details, and we did our best to focus on some of those details in this release. First, some of the highlights. Shortly, you will see a demonstration of validation support for parameters in minimal APIs. It's been a feature that's been in our backlog for a while. It's finally been delivered, and we think the approach and design we took is going to be really something that the community and the ecosystem runs with. We've also got built-in support for emitting server-sent events from minimal APIs via a first-party result type. So now if you're building APIs that take advantage of SSE for streaming, you have that option built in by default. We've talked about OpenAPI 3.1 support in the keynote and a number of community stand-ups. This is a really big deal because it was kind of a collective community effort. It wasn't just on the ASP.NET Core front. We worked with the OpenAPI.NET team to bring that functionality to the Microsoft OpenAPI package, which a bunch of tools in the ecosystem like Swashbuckle and Kyoto use to model OpenAPI documents in memory. So that was pretty neat. We've got XML support for OpenAPI documents. We showed that in the keynote as well. And you know, YAML gets a bad rap these days, but it has tremendous readability benefits. And especially in scenarios like OpenAPI, where the YAML is generated from code, the OpenAPI specification that we have in memory, it's sometimes helpful to not have to read JSON to understand how your API is structured.
All those curly braces and quote signs.
Can't handle them. Nice. Another feature from the backlog that we took a stab at is adding system text JSON support to the JSON patch library. For a long time, JSON patches built-in implementation in ASP.NET Core was based around JSON.NET, but we've modernized it to support system text JSON, so you can take advantage of native AOT support and all of those perf advantages that you get with system text JSON. And one of the other tweaks that we fixed is the way that we handle unauthorized requests and APIs. Your behavior might differ for how you want to handle unauthorized requests if you've got a web app where you might want to redirect to a login page, or an API where you might just want to return a 403 status code and have the client deal with it, whatever it may be. And so we've improved that handling so that we can more accurately detect what's a route that represents an API endpoint and what's a route that represents a view in the implementation. And that lets us be able to make better choices about, hey, let's redirect to login in this case, or hey, let's go ahead and give you that 403 status code, and clients, please deal with it appropriately. So pretty good stuff on the back end.
Another, all very highly requested features, right?
Yes, we are listening.
Yep. All right, so
Yes.
demo.
Demo time. All right. If we jump to my screen, I've got a bunch of code on my screen that I want to walk you through that's going to talk all about validation support for minimal APIs. And I really want to get under the hood with this feature because I think there's a couple of interesting things about it that you would be curious to know. So what does it take to light up validation support for your minimal API in .NET 10? Well, it's pretty simple. All you have to do is call add validation on your service collection to enable validation support. You don't have to do anything else. You don't have to apply attributes on your types or anything else to light up this behavior. One of the cool things we were able to do is actually build on top of the heritage we have with building source generators for minimal APIs to automatically discover parameter types in your request handlers and any validation attributes that are applied on them or any iValidate object implementations that they implement and then register or light up validation support for them. So what that means is that I can keep my handler code pretty clean. If we take a peek at the customer's route endpoint that I have here, it's really just got my input and the response that emits. Everything else is source generated and I don't need to worry about polluting my code with additional attributes. It keeps things focused on that business logic. And if we want to see this in action, we can jump ahead and we can send a request to one of our endpoints. I think this is the customer's endpoint. And we'll see that if a customer has sent a request that doesn't have a valid email, they'll get back a problem details response that says, hey, the email field is not a valid email address. Problem details is a standard that we build upon extensively in ASP.NET Core, and you see that we've done that here for validation. I'll draw your attention to the fact that there's actually an additional field here in my problem details payload. There's this detail property, and it tells me the number of errors that have occurred, which in this case is 1. And that's because the validation support that we have built in actually respects the configuration of the problem details service that we introduced in like .NET 8, I believe. And so I can actually use the existing customized problem details APIs to customize the behavior of the problem details response that's submitted. And what that means is that if you have anything where you're adding additional trace IDs or additional fields into your properties, those light up automatically because all of that configuration is centralized, which is pretty neat. Now, I mentioned earlier that this implementation extends upon the system component model data annotations. So your validation attributes, your iValidate object, et cetera, et cetera. There are, however, options for you to enhance or add custom behavior that doesn't really need to take a dependency on attributes that are on your types themselves. So if we hop into the add validation method that we're using to register our validation services, you'll see that we're registering this custom business rule validation resolver. Resolvers are the core component of this validation logic, and they allow you to describe the validation behavior of particular types or properties. So here in my business rule validation provider, I can describe custom behavior for things like a business product or a business store. So if we jump to what we describe in business product validatable info, you'll see that I've got some rules about the ranges for wholesale and retail prices, categories, so on and so forth. I can use component model data annotations that are built in, like the required and range attributes, or I can define my own ones. We'll see we have a business SKU validation attribute. And all of this lights up by default. So if we go ahead and send a request with an invalid product code, we'll see that we get an error back that says, hey, you tried to register a new business product, but the retail price and the wholesale price were not correct. So you've got to go and adjust that. And all of this lights up automatically when we implement this resolver API and add it to our DI container via the callback. So that's pretty neat. All of this lights up automatically. However, there is an option for you to opt in types explicitly into this validation infrastructure if these types are not used in minimal APIs. As we mentioned, this is a pretty extensible model. We use it in Blazor. We've prototyped it in like plain old console apps as well. And if you want to explicitly opt in a type to validation, you can use the attribute validatable type to indicate to the source generator, hey, although this isn't used in a minimal API, it's used somewhere in my framework, can you please go ahead and generate the validatable type info resolver for it, and it will hook into all of the runtime infrastructure that we have that consumes that. So this is pretty neat. We've kind of taken a stab at tackling a Pretty core gap in minimal APIs, but we've done it in a way that solves problems for Blazor, which didn't have support for being able to validate nested complex types. So we were able to kind of address two issues at once with this approach. I'm really excited to see how folks build with it. It is shipping as experimental for .NET 10. We're hoping in future releases to iron it out and actually ship it as a Microsoft Extensions validation package. So stay tuned for that.
And one more point that I want to make on this. We covered this in the pain point section of the talk, but in fact, input validation is one of the most important things for building secure apps.
Yes.
So it actually hits both of those key goals that we had for .NET 10.
Nice.
All right. So the next thing that we want to show is a demonstration of some of our OpenAPI support. So this is a little test app that I built. It's built on the eShop demo that we've shown a couple of times. So I have the catalog service here, and I'll just show you that this is running in an Aspire container, just like eShop does. And you can see that because we've got a health endpoint. Oh, sorry, I got to start it first. So I say Aspire run.
Amazing. Aspire run live.
Yes.
I love it.
Run.
We get the cute little emojis.
Indeed. We have a health endpoint. Maybe I won't show that at this point, but I do want to show that we now have the OpenAPI being generated. We can probably close that up. And you can see that now it's OpenAPI 3.1, right? That's very cool. We can also generate the YAML form of that. So you can get your OpenAPI in either JSON or YAML, depending upon what you want to do. And something I want to show you about the OpenAPI support. Now that we're at OpenAPI 3.1 and in its full JSON schema, you can now do things like declare nullable types, and they show up here as type null or string, right? And that's actually much more accurate than what was possible in OpenAPI 3.0. So this is actually a really important extension. This is not the only thing that's better in 3.1, but it's one of the things that you will probably notice right away. And Safia also mentioned, you know, the support for XML doc comments. You can see here that we're in the catalog item. So if we go here to our models and catalog item, sorry, I wanted to open that over here. You can see that the descriptions here are now coming from the XML doc comments, and you can only write, you only need to write them once now, and we'll pick up those XML doc comments and show them in the OpenAPI for you.
Beautiful.
All right. So that was the demo of the OpenAPI enhancements. That was it. That's what we had to show for today. We've done a lot of work in ASP.NET Core for .NET 10. We made your apps, we made it easier for you to create secure apps with WebAuthn and passkeys. There's also a bunch of authentication scaffolding that Dan will be showing later in the Blazor talk. We've improved app observability and diagnostics with more metrics, better tracing, better support for OpenTelemetry. We've got targeted performance improvements like the Kestrel memory pool and minimal API JSON deserialization. And we've addressed a number of top key pain points and gaps, things like minimal API validation, support for XML doc comments in OpenAPI 3, and support for OpenAPI 3.1. We've got JSON patch support with system text JSON, Blazor state persistence. That's a big one, and Dan will be showing you that in the talk later. Also some quick grid enhancements in Blazor and improved Blazor navigation. So all of these wrapped up in ASP.NET Core for .NET 10. We've got some resources here that you can look at. You can go get.net today, get.net/10. We have a What's New article that you can go and look at all of the great improvements that we've done in .NET 10 for ASP.NET Core. And there's a link to the docs there so that you can go read our docs, see all of the new, we spent a lot of time actually improving the docs, making sure that the docs were ready for you with all the great new features. So go check out the docs as well.
Nice.
All right. Thank you.